Find the mean, median, mode, and range of 13, 15, 18, 18, and 14. So first, we had to write this from least to greatest. So here I've written from least to greatest. So 13, 14, 15, 18, and 18. So first, let's find the mean. The mean is nothing but the average. To find an average of a set of numbers, we had to add all the numbers, and then we had to divide it by the number of numbers there are. So here there are 5 numbers, and the sum of these numbers is 78, because 13 plus 14, so 18 plus 18 is 36, and 14 plus 15 is 29, and we can just leave 13. So now if we add all these, we get 78. So 78 is the sum of all these numbers. So now we had to divide 78 by the number of numbers there are. There are 5 numbers in total, so we divide 78 by 5. So the mean of this set of numbers would be 78 divided by 5. Okay, next, the median. The median is the middle, or like the middle of the set of numbers. And we can only find the median if the set is listed from least to greatest when dealing with numbers. So since it's already listed from least to greatest, we can just find the middle. So 13 will be crossed out, and then 18 will be crossed out, and 14 will be crossed out, so then 18 over here will be crossed out. So the median of the set of numbers is 15, because that's what we're left with. Next is the mode. The mode is the most repeated number in a set. So here, 18 would be the mode because it is repeated twice, while the other numbers are only repeated once. So the mode would be 18. Next is the range. The range is the distance from the last number to the first number, or the largest number to the smallest number. Since here the largest number is 18, we just had to subtract 18 minus 13, and we should get our range. So 18 minus 13 is equal to 5, so 5 is our range. So for this set of numbers, the mean is 78 divided by 5, median is 15, the mode is 18, and the range is 5. So these are our answers.
My name is Ari, and now we're on question number 2. Draw a pie chart showing the following. 25% of people play sports, 25% do math, 25% like science, and 25% of people like another subject, assuming no one likes or plays more than one subject. So as we know, that we have to make a pie chart. And what I've written here is all the data that we know from this. So we know sports is 25%, math is equal to 25%, science is equal to 25%, and the other subject is 25%. So there are 4 subjects, and I want to divide the circle, the pie chart, into four pieces. So there we go. So let's name this as the sports. Okay, I'm gonna write as 25%. This one would be math, 25%. And then this would be science. Let's just write SC, 25%. And last but not least, another sub. I'm just gonna write AS, 25%. So this is our pie chart to represent all of this and put it in this.
Problem number 3. Draw a bar graph where 15 people study math, 5 study science, 25 study history, and 34 study English. So first let's start with math. So there are 15 people who study math. So right here. let's just say this is math. Next we have science. So science is at 5. So it's like right there. Next is history. So let's move on to the next one. History is at 25. So it's right there. And the final is English. 34 people study English. So 34, that's somewhere a little less than 35. Okay. But when using a bar graph, you always had to label the axes. So this axis would be number of people. And this axis would be subject. You also have to choose correct numbers to go by, correct scales to go by. Otherwise, you'll be dealing with like either very small graphs or very large graphs. You should always choose the correct number, and always go by equal amount. Like so, go by 5s, go by 2s, or go by a certain number. Yep. So this is the answer.
Problem number 4. Draw a Venn diagram representing the following situation. 20 students take only math, 40 people take only science, 10 people take only history, 5 people take math and science, 5 take science and history, 5 take math and history, 5 take math, history, and science. So what I've written down here is all the data from the problem. So we'll be using this as we draw our Venn diagram, and then we tick it off. So what I noticed is that there were 3 subjects. So our Venn diagram is going to be made up of 3 circles. Before we get into the problem, we're going to have to name all of these circles. So this is going to be math. I'm going to write M for short. So this is going to be science, S. This is going to be history, H. So we have to follow these steps and then apply it on here. So number 1, only math equal to 20. Only math means only this part of the circle. Here to here to here. That's only math, and that represents 20 people. Okay, so we tick that out, check. Number 2, only science equal to 40. So only science means here, here, here. So science represents 40 people. So we write 40 people. So check. 3, only history equal to 10 people. So only history would be this to here and here, which is 10 people. Check. Number 4, math and science equal to 5. Notice how they're saying 2 subjects. So that means 2 circles will intersect. Math and science. So that would be this, this, and this. That would be MS, math for science for short, equal to 5 people. Now you're probably wondering, why not this one? Well, we'll get to that. You'll understand more. Okay, so we're just going to take this off. So number 5, science and history equal to 5. Science and history would be science and history. So here, here, and here. So that would be 5 people. So check. Number 6, math and history equal to 5. math and history would be here to here and to here. That would be 5 people. So we write 5. Check. 7. Number 7. Math, science, history equal to 5 people. Notice how they say 3 of the subjects. So that means 3 of the circles will intersect at a certain point. So that would be right here. Here at the center. So that would be 5. This is math, science, and history because all of the circles meet at this point, which is math, science, and history. So now we have represented all of these steps on the Venn diagram. So here is our answer.
Problem number 5. Find the mean, median, and mode of the numbers 1, 5, 7, 9, 10, 12, 14, 14, 15, 15, 16, 17, 15, 19, and 20. So first, we want to write all these numbers in least to greatest. So I've written it here in least to greatest. So first let's find the mean, the hardest one, the average. So I'll just simplify this a little bit to find the sum first. So first thing I see is 3 15s. That's, well, we get an easier number to deal with because it ends with 0 or 5. So 15, 15, 30. So now we're done with these two. Now next, 15 and 10 plus 5 is 15 too. So that and that, so that's another 30. Done with that. Now let's look for anything else. Is there anything else? 19 plus 1. That's 20. 20. And now, oh, there's another 20. Cross that out too. Anything else? Doesn't look like there's much other than that. Oh wait, 14 and 16. So that's 30 again. 30. That looks like it's it. So now we're left with 7 plus 9 plus 12 plus 14 plus 17. Yep, that, oh yeah, plus 30 plus 30 plus 30 plus 20 plus 20. So if you sum all this up, you should get 189. So 189 is the sum of all these numbers. So move this out of the way. We have 189. So 189, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 numbers. So 189 divided by 15. There's no need to simplify because, yeah, I mean, you can simplify if you want to. I mean, yeah, let's just simplify. We know that both of these are divisible by 3. So 189 divided by 3, 63. Yeah, so it's equal to 63 divided by 5. You can't simplify anymore, so the mean is 63 divided by 5. So next, the median. We had to write this from least to greatest again. So we have 1, 5, 7, 9, 10, 12, 14, 14, 15, 15, 15, 16, 17, 19, and 20. Okay, median is the middle, so let's just cross off one by one. So we take away 1 on this side, other side, 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 this side, now other side. So now we're left with 14 as our median. So 14 is our median. Next to mode. Yeah, let's not erase this now. So to find the mode is just the range. Sorry, not the range. The number that repeats the most. If you look through all of this, 14 repeats twice, 15 repeats 3 times, and that's it. So 15 repeats 3 times, and 3 is greater than 1, so 15 is our mode, or the number that repeats the most number of times. Problem number 6. Find the mean, median, mode, and range of 10, 9, 11, 12, and 14. So first, let's write this in least to greatest. So I've written in least to greatest. Let's start with the median. So the median, we cross it off one at a time. So 9, 14, 10, 12. So we're left with 11. And now mode. Mode is the number that gets repeated the most, and since there's no repeats, it'll be no mode. Next is range. The largest number is 14 and the smallest number is 9. So we just subtract those two numbers and we get 5. And 5 is the range of the number set. So now mean. Mean, we just had to add all the numbers, or the average. I'll add all the numbers and divide it by the number of numbers we have. So 9, 11, and 9, 11, and let's just say this. So we have 10 plus 20 plus 26. This is 30 plus 26. 30 plus 26 is 56. So we have 56 divided by 1, 2, 3, 4, 5. So this is 11 and 1/5. So the mean is 11 and 1/5. So the answer are these.
Problem number 7. Draw a pie chart showing the following. 15% of people play sports, 5% do math, 35% like science, and 45% of the people like another subject. Assume no one likes more than one subject. So as you can see here, I've written all the data from the problem. And notice how there is 4 categories. So that means our pie chart is going to be divided into 4 sections. So let's draw our pie chart and put a little dot there. So if we want to approach this, we have to do this proportionately. Like, we have to start from least to highest. So the least one is math, equal to 5%. So I'm going to draw a little thing here, 5%. Now the next one is going to be play sports, equal to 15%. So it's going to be 3 times as big as math, equal to 5%. So let's make this a little bigger, 15%. And now we could check these 2 off. The next one, the next one is science, equal to 35%. So this is science equal to 35% is going to be 2 times as big as play sports, 15%. So let's just draw this line here, the 35%. Now we could check this one off, okay? So now our last one, another subject, equal to 45%. This would be 45%. So we check that off. So this pie chart is our final answer.
Problem number 8. Draw a bar graph where 9 people study math, 15 do science, 2 study history, and 34 people study English. So first, let's start with math. So there are 9 people who study math. First, let's label the axis and make a scale. So 9, 15, 2, and 34. I prefer to go with the scale of 5. Well, this is close to 10. 15 is close to 0 or 5, and this is close to 35. So yeah, I'm gonna go with the scale of 5. So we have 5, 10, 15, 20, 25, 30, 35, 40. Okay, so now we've labeled this, and we know what this is gonna be. This is gonna be the number of students. This x-axis is going to be the subject. Okay, So 9 people study math. So it'll be somewhere around there. Math. So black is math. Next one, we have science. So science is at 15. So 15 right there. Now, science. Next is history. History is at 2, so it'll be like right here. We have history. Next is English, the last subject. So English is at 34, so it'll be all the way up here. So it'll be like right there. So this is the bar graph answer for this problem.
Problem number 9. Draw a Venn diagram representing the following situation. 40 students only take math. 40 people take only science. 40 people take only history. 30 people take math and science. 35 take science and history. 30 take math and history. And 50 take math, history, and science. So right here, I've written all the data from the problem and just wrote it down here. And then we're gonna plot it, use these steps and plot it on the Venn diagram. So before we even start, we have to name these. This is gonna be math, M for short, science, and history. So we're gonna see this first. Number 1, only math. 40 people. So only math means from here to here, from here. That's 40 people. So we're gonna check that off. The second one, only science equal to 40 people. Only science means here to here to here. 40 people. Check. 3, only history. 40 people. So we draw from here to here to here. That is 40 people. Number 4, math and science. Notice how they say 2 subject. So we're gonna have 2 circles intersecting. So that's gonna be math and science. So that is gonna be right here to here to here. That is 30. So check. Number 5, science and history. So science and history would be here to here to here. That is 35 people. So check. Number 6, math and history. So that is going to be right here. Math, here, and here. So that is 30 people. So number 7, math, history, and science. Notice how they say 3 subjects. That means 3 of the circles in our Venn diagram is gonna intersect somewhere. That somewhere is right here. Here, here, here. Which is 50 people. So this is our Venn diagram. And also our final answer. Problem number 10. Draw a Venn diagram representing the following situation. 2 students take only math. 8 people take only science. 15 people take only history. 5 people take math and science. 25 take science and history. 51 take math and history. and 3 people take math, history, and science. So notice that I've written all my data from the problem. I'm going to use that data to plot it on our Venn diagram here. Also notice that there's 3 subjects, which is math, history, science. So that means on our Venn diagram, there's going to be 3 circles. Now, before we even get into our problem, we're going to have to name these circles in our Venn diagram. We're going to name this one math, M for short. And we're going to name this one here science, S for short. And this one is going to be history, H for short. So now, let's use this and then plot it. So 1, math only, which is equal to 2 people. So that's going to be here to here to here. 2 people only. So now we're just going to check it off, okay? So 2, science only. So that's going to be from here to there to there. That's gonna be 8. So 8 people. We're gonna check that one off. 3, history only. So that's gonna be from here to here to here. That is 15 people only. So there, check. 4, math and science equal to 25. Notice how they say 2 subjects. So that means 2 of our circles are going to intersect. So math and science right here. From here to here to here. That is 25. So we're just going to check that off. 5, science and history. So that is going to be here to here to here. So that is 25. So now we're going to check that off. 6, math and history to 51. Math and history would be here to here to here. That is 51. Now we're going to check it out. 7, math, history, and science equal to 3. Notice this time they're saying 3 subjects. That means 3 of our circles are going to intersect at one point. So that is going to be here, here, here. That is 3 people. So, shit. So this here is our Venn diagram and our answer for problem number 10.
Problem number 11. If there are 5 people in a room, 3 of them are studying math, 4 people are studying science, how many people are studying both math and science if one person is studying neither math nor science? So there are 5 people in a room, so let's just say 5. To solve the problem, we're going to draw a Venn diagram comparing both math and science. So this is going to be the math bubble, this is going to be the science bubble. Okay, so it says that 4 people are studying science, so we know that there's going to be 4 here. It says that 3 of them are studying math, so 3 right here. So they're asking us how many people are studying both math and science if one person is studying math nor science. So out of 5 people, 1 person is not studying math or science, so we can subtract 1 from here because we're only looking for the people who are studying math and science. Subtract 1, we get 4. So 4 people are studying math and science, and using this we had to find the number of people studying math and science. So to solve this, first we had to add the number of people studying math and science. So 4 plus 3 is 7. So there are 7 people studying math and science according to this Venn diagram. But since there are only 4 people, we know that there are repeats, or people who are studying both. So if we subtract 7 minus 4, we get 3. So there are 3 people who are studying math and science. And since there are 3 people studying math and science, this becomes 0 and this becomes 1, which means that only 1 person is studying only science and 0 people are studying only math. So the answer to this problem is 3. Problem number 12. If there are 6 people in a room, 4 of them are studying math, 5 people are studying science, how many people are studying both math and science if 1 person is studying neither math nor science? So there are 6 people in a room. Out of 6 people in a room, 4 of them are studying math and 5 people are studying science. So let's draw a Venn diagram. So this will be math, this will be science. So 4 of them are studying math, so there are 4 people here. Let's make this a little better. Okay. 4 people are studying math and 5 people are studying science, so there will be 5 right here. So they're asking us how many people are studying math and science if 1 person is studying neither math nor science. So there are 6 people, 1 person is studying neither of these subjects. So we can subtract 1 from this to get 5 because we're only considering the number of people that are studying math and science. So out of 5 people, we're trying to find out how many people are studying math and science. So to find this, we find the number of people the Venn diagram says there is, and we subtract that from 5. So 5 plus 4 is 9. So the Venn diagram is telling us that there are 9 people studying math and science. But since there are only 5 people in the room, we subtract 9 minus 5 to get 4. So 4 goes in the middle. And since 4 is in the middle, this will be 0 and this will be 1 because 4 people are studying math and science, and since 4 people are studying math, we can subtract 4 minus 4 to get 0, and we can conclude that 0 people are studying math only, and only 1 person is studying science because 5 minus 4 is 1. So the answer to this is 4. 4 people are studying math and science. Problem number 13. If there are 15 people in a room, 7 of them are studying math, 8 people are studying science. How many people are studying math and science if 1 person is studying math nor science? So there are 15 people in a room. Out of 15 people, 7 of them are studying math. So 7 of them are studying math, and 8 of them are studying science. 8 of them. So this is math, and this is science. So they're asking us how many people are studying math and science if 1 person is studying math or science. So since we're only looking for the people who are studying math and science, or math or science, we can subtract the 1 person who's studying neither math nor science. So we get 14. So out of 14 people, 7 people are studying math and 8 people are studying science. So they're asking us how many people are studying math and science. So to find this, we had to find the number of people the Venn diagram says are studying math and science, and we had to subtract that from the number of people who are actually in the room. So there are 8 plus 7 is 15. So the Venn diagram says that there are 15 people here, but there are only 14 people in the room. So we had to subtract 15 minus 14 to get 1. So 1 is the number of people who are studying math and science. So we put 1 here, then we had to take away 1 on this side, we take away 1 on this side. So this gives us the answer of 1 as the number of people who are studying math and science. Problem number 14. If there are 25 people in a room, 9 of them are studying math, 21 people are studying science. How many people are studying both math and science if 1 person is studying math nor science? So there are 25 people in a room. Out of those 25 people, 1 person is not studying math nor science. So we can subtract that 1 person to get 24. So out of those 24 people, 9 of them are studying math and 21 people are studying science. So let's draw one Venn diagram. So 9 of them are studying math. So in the math section, 9 of them are studying math and 21 are studying science. So science, 21. they're telling us to find the intersection or the number of people who are studying both math and science. So together there are only 24 people, but in the Venn diagram there are 30 people. 21 plus 9 is 30. So to reach our total number here, we had to subtract 30 minus 24 to get the intersection. So 30 minus 24 is 6. So there are 6 people studying both math and science. Problem number 15. If there are 61 people in a room, 33 of them are studying math, 38 people are studying science. How many people are studying math and science if one person is studying math nor science? So there are 61 people in a room. Out of those 61 people, one person is not studying math nor science. So we can subtract that one person. So, sorry, 61. So we get 60. So 60 people are studying math and science, or math or science. So let's draw a Venn diagram. So in math, there are 33. In science, there are 38. So we're supposed to compare the number of people who are studying math and science according to the Venn diagram, and the number of people in the room. So there are 71 people studying math and science according to the Venn diagram, but there are only 60 people in the room. So to find the number of people in the intersection, or the number of people who are studying math and science, we gotta subtract 71 minus 60. That gives us 11. So 11 is intersection, or 11 is the number of people who are studying math and science. So 11 is our answer. Problem number 16. If there are 20 people in a room, 10 of them are studying math, and 10 people are studying science. How many people are studying both math and science if one person is studying neither? So there are 20 people. So out of those 20 people, one person is studying neither subject. So we can subtract that one person. We get 19. So I'll start off in diagram now. So in math, 10 people are studying math, and there are 10 people studying science. So to find the number of people who are studying both subjects, we had to add these two numbers and subtract it from the total number of people there are actually in the room. So it's 20 minus 19. This gives us 1. So there is one person who's studying both subjects. Problem number 17. If circle A has a total of 5 dots, circle B has a total of 5 dots, and they both shared 1 dot, how many dots would be in A union B? So to solve the problem, we gotta use the union formula. Now, union formula is A union B is equal to A plus B minus A intersection B. So this U, it means union, so both of them together. This upside down U means intersection, or the parts that intersect. It's going to be clearly seen on a Venn diagram. So union would be this entire thing, and intersection would be this part right here. So here they give us everything. So we know that circle A has a total of 5 dots. So let's take A as 5. Circle B also has a total of 5 dots. So let's take B as 5 too. So, and they say that both of them together have 1 dot. So they share 1 dot. So this is the intersection. 1 is the intersection because that's like the intersection pretty much. So it's 5 plus 5 minus 1. So if you solve this, you get 10 minus 1, which is equal to 9. So 9 is A union B. So 9 is our answer. Problem number 18. If circle A had a total of 5 dots, circle B had a total of 5 dots, and they both shared 1 dot, how many dots would be in A intersection B? So an intersection is the intersecting parts in the Venn diagram. So it would be that part. So here, circle A and circle B both have 5 dots. And they're telling us that they both shared 1 dot. So if they both shared 1 dot, that means that 1 is what's in this portion. So, and that's what intersection is. A intersection B is the intersecting part between the 2 circles. So we know from that sentence that A intersection B is equal to 1. So 1 is our answer. Problem number 19. If circle A had a total of 5 dots, circle B had a total of 5 dots, and they both shared 1 dot. There are 15 dots total. How many dots are in neither A or B? So there are 15 dots in total. So we have to use the formula. First, let's find how many dots there should be. So we have 5 dots for A, 5 dots for B, and then minus 1, minus the intersection. So the intersection is 1 because they said that they share 1 dot. So if you put this into the formula, you get 5 plus 5 minus 1, and that gives us 9. 9. So there's supposed to be 9 dots, but there are 15 dots. So all we had to do is subtract 15 minus 9 to get 6. So there are 6 dots that are neither A or B. Problem number 20. There are 10 students in the classroom. The mean of their age is 10. 3 people have an age of 5. The rest of the students have the same age. What is their age? So to solve this problem, first I took each individual age as a letter. So A plus B plus C plus D plus E plus F plus G plus H plus I plus J. So that's the sum of the first 10 ages. Since we're looking for mean, average, it's the sum of all their ages divided by the number of students. So there are 10 students now. So this is the sum of all their ages. We divide it by 10, and it says we get 10 because the mean is 10. So we get 10. So since we're supposed to find these letters, we had to isolate them. So I multiply both sides by 10 to get rid of this, and I get A plus B plus C plus D plus E plus F plus G plus H plus I plus J is equal to 100 because we're supposed to multiply both sides by 10. So A plus B plus, yeah, you get the point, is equal to 100. So A is equal to 5 because the first three people have an age of 5. So A is equal to 5, B is equal to 5, and C is equal to 5. So we have 5 plus 5 plus 5 plus D plus E plus F plus G plus H plus I plus J is equal to 100. So if we sum this up, we get 15. So 15 plus, now, so that we don't have to write all this again, let's take a look back here. 3 people have an age of 5. The rest of the students have the same age. So now that we've taken out 3 students, we know that the rest of the students have the same age. So we'll take them all as one variable. So we'll have plus x plus x plus x plus x plus x plus x 1, 2, 3, 4, 5, 6 plus x is equal to 100. So now we're trying to isolate the x's because we're supposed to find the age of the rest of the students. So we isolate the x, we subtract 100 minus 15, and we get 1, 2, 3, 4, 5, 6, 7. 7x, x plus x plus x 7 times is 7x. Repeated addition is multiplication. So 7x is equal to 100 minus 15. 100 minus 15 is 85. So 7x is equal to 85. You divide both sides by 7. X is equal to 85 divided by 7. And we can simplify this. Well, we can't really simplify this, but we'll make it a mixed number because it's an age. 10 and 15 over 7, that can be reduced one more time to 12 and 1 over 7. Yes, 12 and 1 over 7. So 12 and 1 over 7 is our answer. That's the age of each leftover kid.
Don't forget forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!